Hey, Algebra 1. I made the worst choice in slide presentation, but this is section 1 for the distributive property. Hopefully you can see most of the other slides. We did skip section 1.3 and we'll talk about that in class. Your vocabulary terms are as follows: like terms, simplest formed, coefficient, and distributive property. Like terms are merely terms that contain the same variables with corresponding variables having the same power. The really best way to do this is to look at some examples. If you look at these terms, none of them are like terms. This is 2x, this is 12x squared. They're not alike because they have the same variable, but they do not have the same corresponding power. Notice 4xy also shares the x in common, but it has an extra y, so all of the variables aren't shared. And obviously 3z has no partner, nothing else has a z. And y would look like y looks like it is similar to the 4xy, but it's only similar, it's not the same because it doesn't have the xy. So what are like terms and what do they look like? So we're going to play a little game. And this game is match those like terms. So I have all of these terms here, and which ones are like? Well, 2x doesn't seem to have a partner, but it does in 1/2 x. Why? They both share the same variable to the same power. Let's see if we can find a match for 12x squared. Is there a match? No, not among these other guys. So that guy doesn't have a match. I don't have to cross it out. That was probably unnecessary. A little bit cruel. Sorry, 12x squared. All right, 4xy has a partner here because they share the same variables and to the same power, and y shares the same variable with this negative 2y. So we've matched all of them. Z squared does not have a match in 3z because they are not to the same power. Our next vocabulary term is simplest form. To make an expression, or make sure an expression is in its simplest form, you want to make sure there's no parentheses and there are no like terms. So if I have 2x plus 3y plus 1 plus, I'm doing a lot of addition here, 2 times 3 minus x. Let's say I had something wild like that. This definition tells me that I cannot have any parentheses nor any like terms when I'm done with the expression, and this clearly is not in its simplest form. So to put it in its simplest form, I'm going to try to get rid of the parentheses. We remembered we do that by distributive property. We talked about this last year. We'll talk about it again now. 2 times 3 is 6. 2 times a negative x is a negative 2x. And then I see I've got some like terms. These guys are alike. And I see no other like terms. So when I join these like terms together, 2x minus 2x, those go away. I'm left with 3y plus, 1 and 6 are like terms, 3y plus 7. And this would be considered the simplest form. So again, simplest form is no parentheses and there's no like terms. Notice I have no more like terms because I joined everything together. The word coefficient is one that we've used before, and really it is the number that is being multiplied by a variable. So it says, the definition says this refers to the numerical factor of a term. So each of these can be considered individual terms. What's the number that's being multiplied here? What is the number, the numerical part? And that is 5 in this case. So the coefficient is 5 here. The coefficient here is negative 3/2. Or negative 3 over 2. The coefficient, I'm going to skip, I'm going to go over here for now. Coefficient here is just 5, which you expected. What's the coefficient here? Give yourself a moment to think about it. It's not negative, but it's negative 1. Does that make sense? Because negative 1 times a would give me negative a. All right. The distributive property is one of these things that we've talked about before, but when you see it written down in symbols, sometimes it's a little bit hard to unpack. So we're going to talk about that. So the distributive property says when I have a times a quantity of b plus c, it is equivalent to this thing here, a times b plus a times c. And similarly, when I have a times the difference of b minus c, I get this value here. They're equivalent. And I could also change the order. I could have the quantity first and then the number that I'm multiplying by on the outside, on the right side, and I'd still multiply through in either case. So a couple of examples would be if I had 3 times 2 plus 1, that should still be equal to 3 times 2 plus 3 times 1. 3 times 2 is 6 plus 3 is 9. Most of you probably would have just taken the 2 plus the 3, got a 3. 2 plus 1, sorry, got a 3. And then 3 times 3 got 9. And you realize we get the same thing. And you can feel free to go ahead and just apply this principle, this property, anytime you have this situation. We've reached our first example, and example 1 is called mental math, but we're going to write out the thought process behind what you guys can do mentally. It says use the distributive property to rewrite 7 times 49, then evaluate. So that's pretty unclear, and there honestly are infinitely many ways where you can do it. But a simple way would be to take 7 and multiply it by 50 minus 1, because the theory is it's obviously easier to multiply 7 times 50 than 7 times 49, and 7 times 1 than 7 times 49. So when I have 7 times 50 minus 1, I would do 7 times 50, which is 350, and then so I have to multiply that times that, and that times that, then 7 times -1, which is -7, and then voila, it is much easier to subtract 350 minus 7 than to do all this tough math calculation. Maybe it is, maybe it isn't, but this is what we just want to demonstrate this practice. So 350 minus 7 is 343. Okay, our second example, we're going to be taking a look at some algebraic expressions. We're going to rewrite each expression using the distributive property. So, if we're to do this, what I'd like us to do is take a look at the 7, recognize that we need to multiply it by each term inside the parentheses. So 7 times 3w gives me 21w, and 7 times a -5. I look at that as a -5. 7 times a -5 is going to give me a -35 or -35. We can talk about that more if that seems strange. Example B is always kind of awkward because the value is on the right side, but again, whatever number is out there that needs to be multiplied, we're going to multiply it by each term inside the parentheses. So this becomes 24v squared plus 4v minus 12. Example 3 gives us an opportunity to practice combining like terms. So we're going to simplify each expression, keeping our mind in gear to combining like terms. So what I see here is that I have 17u and 25u. They're both the same term because they have the same variable to the same power. They're both to the power 1. So I can simply add 25u's plus 17u's, and I get 42u. Pretty straightforward. Let's look at this next example, example B. What I see is I've got everything has a t in it. Are they all the same term? Are they all like terms, guys? I hope you're screaming no, because they're not. 3t and minus t are both the same term, but 6t squared is not the same because it has that squared. And even though it's a t, it still has that squared. That's a problem. I'm going to draw a line here so we don't get confused. So the 6t squared must stay there, but 3t minus 1t is going to give me a positive 2t, and this is as simplified as it gets. Okay, so we've come to our fourth and final example. I had to do a little bit of a change there. That should be yous and not us, but that's okay. You guys are very forgiving. Example 4, we're going to write and simplify each expression, and so we'll talk about that. It says use the expression, and here's the expression that we're using. I'll highlight it. Twice the difference of 3x and y increased by 5 times the sum of x and 2y. So looks like I've blanked it out, but you guys can see that we have this expression and we've got to figure out how to write it as an algebraic expression. That's our first job. All right, hopefully that makes it a little bit more bearable. I took the highlight off and just underlined. Okay, so it says twice the difference of 3x and y increased by 5 times the sum of x and 2y. That is such a lot. And we're at the first step, we're asked to write an algebraic expression for the verbal expression. So when I hear the word difference, I know that that means to subtract. So twice the difference. Twice means to multiply by 2. So I'm talking about twice the difference of something. What's the difference of what? 3x and y. So twice the difference of 3x and y. That seems to satisfy that first part. And now it's increased. What does increased mean? Yes, yes, children, quiet down. It means plus or to add. So we're going to increase it by what? 5 times something. 5 times the sum of x and 2y. So I'm increasing it by 5 times something. What's that something? The sum. Sum means addition. I know you know that. X and 2y. Look it over. Feel comfortable. Because now we're going to simplify. Now to simplify, we know we need to get rid of all the parentheses, and we do that by the distributive property, and then we're going to join like terms so that there's no more like terms to be joined. So I'm going to literally just take this right here and do what I know to do. Let me grab a colorful pen here, and I'm going to multiply 2 times 3x, 2 times y. I'm going to multiply 5 times x and 5 times 2y, and then we'll get a new expression, and I'll keep this in green. So 2 times 3x gives me 6x. 2 times a negative y gives me a minus 2y, plus 5 times x gives me 5x, and 5 times 2y gives me plus 10y. And we're done. Just kidding. We have a bunch of like terms that we need to join together. This guy and this guy, and this gal and this gal. I've made this look confusing, so I'm going to take all of that off, and we're going to join the x terms together, and that's going to give me an 11x. And then when I join the y terms together, notice I have a 2y, negative 2y plus 10y, and together that's going to give me a positive 8y. Yay! And I think pretty much that's it. Okay, good friends, here it is, our assignment, pages 27 through 29. And you've got a number of problems to do, but we'll do them together in class, and it'll be awesome. And we'll talk a little bit more about section 1-3 and why we didn't cover it. Have an excellent evening. Thanks.